So if you're interested in one of those, let me know, contact me, or just let me know afterwards, and we can get you one. I can send you one, or I might even have a couple in my bag. I can get you one today. All right? Control circuits. I want to talk about control circuits briefly, and I want to make sure we save a little time for questions too, if we had any. But safety circuits, essentially, we're looking for a control reliable or a well-designed. Let's use just some generic terms. We're looking for a well-designed safety circuit. And what constitutes a well-designed safety circuit? Okay? Well, part of that is we need the ability for that safety circuit to achieve a safe state in the event of a failure within the safety-related components. So wait a minute. I mean, you got to read that a few times before it really sinks in. Okay? Especially if you're not a controls engineer, you got a safety system. And if the safety system fails, we have to achieve a safe state. Achieve a safe state in the event of a failure. But that's what my safety system is supposed to do. If the safety system fails, how do I make sure? Well, the way that we do that, there's a design methodology for that. I have another definition here. This is a little bit older, so this is out of B1119, so that's an ANSI standard here. This is a little bit older definition. A single component failure within the device system shall not prevent normal stopping. You see why they rewrote it. Shall not prevent normal. Okay. But shall prevent a successive machine cycle. So even if it fails, we have to make sure that we don't allow the machine to run again. And the way we do that is through redundancy and monitoring. That's the cheat code, right? So the cheat code is redundancy and monitoring. If I have one relay that does something, I add a second relay that does the exact same thing, and then I monitor those two relays. Now, one of them is doing the work, right? And they're both doing the work. And then one of them is monitoring. And if it sees a mismatch in what it's supposed to see, then that monitor tells me, hey, you got a problem, you got a failure in your safety system. I'm the monitoring relay. I detected that failure. And because I detected it, I'm not going to allow this machine to run until you fix that failure. So there's an easy way to do that. A safety monitoring relay, essentially, if you've got relay logic, essentially will accomplish that. Now, it can get as complicated as you want, and that will let your controls engineers dive into all the different ways that they want to accomplish that. But with mechanical relays, there's a simple way to accomplish that. That's through redundancy and monitoring. Through modern safety controllers, have this built in. This methodology is designed into all modern safety controllers. It's not unique to the Omron brand. I wish it was. We'd sell a whole lot more controllers. But if you've got a safety controller from a competitor, that is accomplishing the same thing. This is how we're achieving it. Okay? So the idea is that we don't want to tie our input devices, we call ILO, you heard that before? ILO, you seen that? Input, logic, output, right? So input, logic, and output, right? So input would be our safety device. We've got a door lock on the machine, or we've got an area scanner, or we've got a light curtain, and we breach the light curtain, whatever it may be. That sends an input to the logic or to the control, and then that's going to send an output to some device, or another relay, a drive, a valve, whatever that may be on the other end, right? So if we just tie in here, though, we talked about it, and you confirmed, because you're an electrician, or you're an electrical engineer or electrician? Controls engineer, okay. But we confirmed that if I have a single relay here, I could have a complete failure that would lead to an unsafe condition. So I don't want to do that. So we'll get rid of that. And then what we do want to do is have some sort of logic control in place. And that can be as simple as a relay. It doesn't have to be a complex control. It could be a simple safety monitoring relay that we tie in and we allow that machine to run as long as we have a safe state. And it could be as complex as a safety controller. And however, your system design will drive what you put in the middle here, right, in the logic piece. That'll all be driven by your system design and what's important to you.